Have you ever stopped and wondered what's really going on inside the mind of a machine? I don't just mean the lines of code, but the actual formal logic it uses to process information, to form beliefs, and to decide what it truly knows. Well, that's exactly what we're going to get into.
This is the big question, right? We're going to peek behind the curtain at the formal systems that let an AI reason about its own state of knowledge, giving us a rare glimpse into the logical engine that drives artificial intelligence.
So, here's our roadmap. We'll start inside the AI's inner world. Then we'll untangle the difference between what it knows versus what it merely believes. From there, we'll see what happens when an AI has to change its mind, how it handles brain-twisting paradoxes, and finally, wrap it all up with why this is so critical for building a truly rational machine.
All right, let's kick things off. To even start, we have to understand the language an AI uses to think about its own knowledge. And I want to be clear, this isn't a programming language like Python or Java. We're talking about a formal framework for logic itself.
And that framework? It's called modal logic. The easiest way to think about it is like a special kind of grammar, but instead of for words, it's for concepts like possibility, necessity, knowledge, and belief. It gives the AI a really structured way to handle ideas that go way beyond simple black and white facts.
Okay, so within this logical world, there are two states that are just absolutely fundamental: what an AI knows and what it believes. Now, they might sound kind of the same, but in the world of AI logic, they are critically fundamentally different. Knowledge, which is handled by something called epistemic logic, is all about certainty. It's about what must be true based on cold, hard proof. Belief, on the other hand, which falls under doxastic logic, is all about what's plausible. Formally speaking, an AI believes something if it knows it's more likely to be true than not. This distinction is literally the engine that allows an AI to make smart judgments, even when it doesn't have all the facts. But what happens when an AI gets a new piece of information that completely contradicts something it already believes? I mean, this is where things get really interesting. An AI can't just be a static encyclopedia. It has to be able to adapt and update its entire worldview.
For a long time, the classic blueprint for this process has been something called the AGM model. It's basically a set of principles that lays out how a rational agent should logically and, very importantly, consistently revise its beliefs when it gets new data.
So let's break that down. Just picture a digital detective, okay? It has a whole system of beliefs about a case. That's step one. Then, a new clue comes in that contradicts one of its main theories. That's step two. Now, according to the AGM model, the detective doesn't just throw its whole case file in the trash. No way. Instead, it carefully revises its beliefs to fit this new clue in, while changing its existing theories as little as possible. That's step three. Minimal logical change.
But there's a huge catch with the original AGM model. It's a little too trusting. It's naive. It just assumes that any new piece of information it receives is automatically true and has to be accepted. And in the real world, we all know that's just not how it works. Info can be wrong, it can be misleading, or it could come from a source you just can't trust.
So, obviously, these models had to get smarter. Newer approaches, like what's called credibility limited revision, build on that AGM foundation, but add a critical new feature: a dose of healthy skepticism. These more advanced systems can actually evaluate how credible a source is and then decide whether to fully accept, partially accept, or just flat out reject new information. This makes the AI's reasoning so much more robust and realistic. All right, now we are diving into the deep end. We're talking about the biggest, thorniest challenge for any logical system, human or artificial: the paradox. This is when a system of logic, if it's not built just right, can literally tie its own brain in a knot.
You've probably heard the classic liar paradox. This statement is false. Just think about it. If the statement is true, then it has to be false. But if it's false, that means it must be true. For us, that's a fun little mind bender. For an AI, it's a potential system-crashing infinite loop of contradiction. The AI has to have a way out.
And that way out comes from a field called axiomatic theories of truth. Think of these as the logical guardrails. Systems like the crypto-Pfefferman theory create a really sophisticated, layered definition of truth. It basically lets the AI analyze a self-referential statement like the liar paradox, recognize it as a paradox, and then safely set it aside without letting it break the whole system. It's a brilliant logical escape hatch. Okay, so let's pull back for a second. We've gone through modal logic, belief revision, and these mind-bending paradoxes. I know it all sounds incredibly abstract, but this stuff is the absolute bedrock for building AI that we can actually use in the real world and, more importantly, that we can actually trust.
So why does all this matter? Well, for one, it's what makes an AI's behavior predictable and reliable. It's what allows multiple AIs to work together even if they have conflicting information without just grinding to a halt. It's a huge piece of AI safety, preventing those catastrophic failures that paradoxes could cause. And really, at the end of the day, this formal reasoning is the foundation for building machines that don't just process data, but can actually begin to understand what it means.
Which leaves us with this final thought. We've basically laid out the logical skeleton for a rational mind, one that can know things, believe things, update its beliefs with skepticism, and navigate paradoxes without breaking. It really makes you wonder, what's the next piece of the puzzle on the path to creating a truly rational artificial intelligence?